Bonjour. Je suis Michael. Parapaz français. That's the only French word I know. I come from Japan, Far East Asia. I am a cloud engineer, architect. I help devs and ops manage their infrastructure, their development process, and their cloud architectures. I'm involved in the Japan AWS users groups. There's like thousands of members, 50 subdivisions nationwide, probably one for each prefecture. I'm also the core member of the Serverless Community in Japan. There's over 600 members, and we had Serverlessconf Tokyo in the previous 2 years, over like 400 attendees. Now, I'm going to tell a very short story of one example of using serverless to help accelerate DevOps in one project that we had. And we're going to go through the background, some issues, solution architecture, and a demo, if we have time. So this is a typical setup that we had, a very simplified one. We had some chat ops, Jenkins, bots, deploy servers, which the devs would use them to deploy their environments to production staging and etc. And the ops would use Terraform to manage the servers. However, we had some issues, like some of the servers would be resource bound, CPU memory, maintenance with disk usage, and like server failures. That was like a headache. We had to keep track of updates with like Ruby. We were using Ruby and some Go. The versions like those, Jenkins, Docker versions. And most of the process would be sequential execution, so we had to like wait on deployments. And as we added on more projects, there was more load. And of course, there were some new demands from the devs. They wanted more faster concurrent deployments. They wanted to test and deploy multiple versions, multiple branches. And they basically wanted on-demand environments where they could just easily test with like QA and other third-party services. And we were also migrating to ECS. And the solution that we came up with was to just automate the whole process of creating the environment. When the developer would, push a branch to GitHub, it will call the API gateway. It would trigger API gateway request, which it would call Lambda, and using step functions to orchestrate all the different processes of creating the environment in EC2. And we'd use Circle CI for the deployment. We could have used code pipeline, code build, but what fun is that? And we're also using it for like different projects anyways. So the process is so this is one branch. We would have a ECS cluster, one service with a load balancer on ALB. And when the user creates another branch, it would just create a new port, a random port on the same ALB with a different service and task definition, and so on. Now, creating the environment on EC2 is easy. Just create a target group, an ALB listener, ECS service, and deploy if necessary. But in reality, you have to wait for the ECS services. And the process of destroying the environment is similar. You have to stop tasks, delete services, delete listeners, delete the target group, but you have to wait for the tasks to stop, and the deletion of the service would take some time. So we used step functions to coordinate all this, and because sometimes getting the images from ECR and running the tasks would take a long time depending on the images that we used. And step functions is easy to use with the serverless framework. And my very good friend Horike in Japan, he's the author of the step functions plugins. and it enables you to not use JSON, which I personally think humans should never touch with. And it makes it somewhat less painful. You can write YAML with it. It's not optimal, but it's slightly better. And as a demo, I've pre-recorded my thing because it's easier. Right here, we're checking out the GitHub Git branch, pushing it to GitHub, and it triggers the webhook to an API server. And right here, you can see it already created the ALB target, listener, and ECS service. And step functions, you can see it running and get a visualized workflow. It's waiting for the service creation, and it's done with the endpoint, and now it's deploying. Now this is just fast because it's just a simple project, but usually it takes some time to create. I've skipped a couple of minutes here just to yeah, there it goes. So that's it. And destroying is very similar as well. When you merge your branch, you obviously delete it. And here you delete it, it gets the request again. And you can see it destroying the environment by stopping the tasks. And then it'll wait for the tasks to stop. You can see the tasks are still running. It'll constantly poll within every 5 seconds or however many you want to specify. And yeah, it'll just delete the service and delete the ECS environment after. So yeah, this is gonna take some time. We'll skip. So this is just a simple example of using serverless to make development easier for our whole team. The devs are happy they have on-demand environment. The ops aren't stressing out managing different servers or environments. And we try serverless because of the concurrency that we can get, the scalability, less maintenance, and more coding. No maintenance, easy deployments with frameworks, especially with the plugin. Afterthoughts. So we're overall satisfied. It scales pretty well with several different projects. The visualization is awesome in step functions, but as the recurring topic in this at Serverlessconf, there is a complex observability where logs are spread across different log streams. When you call a step function, you use a lot of lambdas, and going through each log stream for the lambdas is burdensome. So yeah, I'm sure this will be resolved in the future with upcoming products and services. I've created a sample on GitHub. I named it ECS Deity. It's a deity that basically takes care of creating and destroying worlds. Feel free to take a look at it. Maybe send pull requests or feature requests. And that'll be it. Merci.